To really know what makes a great city work, you have to peel back its skin and expose its secret life force. A system of incredible complexity and technology that millions depend on, but few understand. A fantastic voyage now begins, a journey deep inside the world's megacities. It's the second largest city on Earth, and the most important city in Brazil. More than 10 million people live in Sao Paulo. In the same space, you could fit the entire population of Greece. But fitting people isn't the biggest problem. The problem is where to put their trash. Every day, Sao Paulo generates 14,000 tons of garbage. The weight of the Leaning Tower of Pisa. Once it ended up in vast open dumps, magnets for rats, disease, and people. The poorest of the city's poor groped for dinner in other people's garbage. An entire megacity was going to waste. Sao Paulo is a victim of its own success. For decades, Brazil's wealthiest city has lured millions of poorer residents from the countryside, with visions of striking it rich. The result? Runaway growth, stifling pollution, and mountains of trash. Now Sao Paulo has embarked on a green revolution. Like no place on Earth, this megacity is attempting to salvage itself through recycling. The catalyst? The same motive that created the problem: money. Today, Sao Paulo harnesses hectares of trash to produce mountains of energy. It leads the world in reusing a universal piece of packaging. Sao Paulo's scientists have cracked a technological enigma that baffled the world's industrial giants. And a homegrown urban renaissance is bringing entire neighborhoods back from the dead. Sao Paulo is painting itself in new hues: the green of ecology and the green of cash. Two shades, but one result: the beginnings of a life-changing revolution. The revolution started here. Bandeirantes is one of the world's largest landfills. It's also a power plant. It runs on an endless supply of cheap fuel. Not coal, not oil. Garbage. Bandeirantes was once an empty valley, the size of 175 football fields. Now, trash rises in layers 7 meters deep. In between, a 20-centimeter layer of dirt. As the valley of trash grows, the pressure creates a foul liquid byproduct called leachate. To prevent contamination of the soil and groundwater, the base of the landfill is lined with a huge polyethylene blanket, 5 millimeters thick and impermeable. As garbage decomposes, it naturally produces methane gas. Trapped beneath the dirt, the methane is extracted through 200 vertical tubes. 1 ton of trash produces up to 200 liters of gas, enough to power 1 house for 1 hour. Layer by layer, Bandeirantes fills with energy. In 1 year, this landfill can create enough electricity for 400,000 people. Bandeirantes operates around the clock, year-round. Every day, it grows by 6,000 to 7,000 tons. Antonio Carlos Delbin is a technical director for Biogas, the company that harnesses the gas.
Here where we're standing, there are several layers of trash on top of each other. Each of these layers is more or less 5 to 8 meters high, and the total depth is 80 to 90 meters, from which you can conclude this used to be a big valley.
If garbage were a drink, Sao Paulo's would be champagne. Few cities throw out such a heady brew. Banana peels, eggshells, coffee grinds.
The domestic trash produced in Sao Paulo is rich in organic matter, different from countries in Europe and the US.
Less packaging, more produce. Up to half the landfill is organic matter, rich in methane. Yet all that potential energy once went up in smoke. Losing it was cheaper than tapping it.
These are old gas burners, where the gas used to be freely burned and sent to the atmosphere.
Adriano Giogo once served as Secretary of the Environment for Sao Paulo. He helped make the city's garbage crisis disappear by tapping trash for fuel. The technology isn't new. The incentive is a United Nations treaty to reduce global warming called the Kyoto Protocol. Under the treaty, poor countries sell richer countries pollution credits, the right to produce more pollution. In return, poor countries reduce their own pollution. Sao Paulo gets half the money Brazil earns from this plant by burning clean methane.
Today we have a revolution going on here. Those houses you can see in the back, they receive electricity produced by this landfill, by this old open trash dump.
The process is not only clean, it's invisible.
This is a mountain of trash. There are 30 million tons of trash here. Where are the signs of the landfill? Wherever you see those black tubes, they are the machines that collect the gas.
As the gas accumulates, it flows to the generation plant. Engineers chill the gas to 13 degrees Celsius. As it cools, water condenses and flows off, leaving 50% pure methane. To comply with the Kyoto Protocol, engineers measure the gas. The result shows how much pollution the plant has kept from entering the atmosphere and how many pollution credits Brazil can sell. In the final stage, gas flows to 24 generators to be burned as fuel. The electricity travels to the local utility, then to residents of Sao Paulo. Waste into watts. The entire process belies the old adage, garbage in, garbage out. From a valley of trash flows a river of power. Its only limit, the size of the landfill. Bandeirantes can hold about 20 years' worth of trash. First 5 years produce the most methane. Then production gradually declines. One day, even mighty Bandeirantes will go extinct. But then the landfill itself may be recycled as a park. And what of the cast-offs who once scavenged the dumps? Trash has transformed their lives, and they've transformed Sao Paulo. The cast-offs are now alchemists who turn ordinary metals into a golden opportunity. In some religions, reincarnation is an article of faith. In Sao Paulo, it's a fact of life. It happens millions of times a day, right before your eyes. In this megacity, metamorphosis is the only constant. Once a tiny Jesuit mission, Sao Paulo became the financial heart of Brazil. 2 centuries ago, the city prospered by exporting coffee. When the market collapsed, Sao Paulo reinvented itself as a hub of manufacturing. Prosperity brought the biggest change of all: people. Every 2 decades, the population doubled and the skyline blossomed. Yet runaway growth brought polluted air, fouled rivers, and vanishing green space. In blight, Sao Paulo now finds gold.
Every day we receive more than 10 tons of cans here, and we recycle 9 million cans.
Jose Roberto Gioza is president of Tomra, South America, the largest aluminium recycling company in Latin America. Placed end to end, one day's supply of cans would stretch from Paris to Rome. A year's worth would circle the globe 10 times. Tomra runs 14 collection centers like this one in Sao Paulo. Not only do they recycle more than anyone else, they do it faster.
From the moment the can is consumed and becomes scrap to the moment it goes back to the supermarket shelf, it takes only 33 days.
From start to finish, Sao Paulo sets the standard for recycling. The proof? Just follow the life cycle of a single can. Guioma de Macedo spends her days collecting paper, cardboard, plastic, glass, and aluminium. In Sao Paulo, 20,000 people earn a living collecting recyclables. They're called catadores, trash pickers. In this megacity, that's no insult. It's a job. For some, it's a whole new life. In Brazil's richest city live some of its poorest citizens. 1.5 million people eke out an existence in the city's notorious slums, the favelas. Now Sao Paulo is training the jobless, the homeless, and the hopeless.
It's a way of taking thousands of people off the streets and making them citizens through a regular job in a specific place.
Recycling doesn't just earn money, it saves money. Using old cans to make new ones takes 95% less energy. Or you can make 20 cans from recycled aluminium with the same energy it takes to make 1 can from virgin ore. Throw a can away is like filling that can halfway with gasoline and dumping it down the drain. Recycling a single can saves enough electricity to run a small TV for 3 hours, or to light a 100-watt light bulb for almost 20 hours. At Tomra's collection center, charities can trade cans for goods. 5,000 cans will buy an electric fan, 6,000 cans a wheelchair, 180,000 cans a photocopier. Today, 74 cans will buy lunch.
É trabalho assim que muitos ainda, né, muitos.
It's a job that many don't consider important, but for us here it's worth a lot because it helps us earn our bread.
The catadores have separated their recyclables, and the can collected by Mrs. Macedo now begins its journey to Tomra and a new life. First stage. A vibrating conveyor belt sifts large items not made of aluminium, like paper and plastic.
Then the can arrives at the end of the belt, where a magnet separates other impurities like steel cans and other materials that are not aluminum.
Steel compromises the flexibility of aluminium. To weed out heavy metal, this can will eventually pass through 3 levels of sorting. The goal? Only 1 part steel per 1,000 parts aluminium. Next, the can enters a giant rotating cylinder called a trommel. From a hole in the middle, more foreign objects disappear: straws, labels, and steel fragments. Then a third sorting. An electromagnetic belt removes objects that escaped the trommel.
So what we have here is only very clean cans, ready to be pressed.
They travel through a tube into a silo, then to a hydraulic press. It crushes and shapes the cans into blocks weighing precisely 12 kilograms.
All the blocks come out exactly the same size and weight. So in a continuous cycle, the press makes blocks like this. You can see here the can we started with back at the beginning of the process. Here it is.
The blocks form a self-contained pallet. No wood, no extra weight, no extra expense. Even the slots for the forklift are built in.
It's more or less 1,050 cans here. Each of these pallets weighs exactly 750 kilograms. So here we have 100% clean cans ready to be taken to the reclamation facility.
Every day, a truck leaves with about 14 tons of cans. 80 miles away, Mrs. Macedo's can will take on a new form and a new identity, transformed in a river of fire. This is Tomra's recycling plant. It shuts down only for maintenance and holidays. Otherwise, it runs 24 hours a day, 7 days a week.
We receive around 120 tons of scrap daily.
For plant manager Marcelo Schuka, recycling is more than a job. It's a mission.
Se essa lata não fosse reciclada hoje, certamente ela levaria.
If this can were not recycled today, it would take thousands of years to decompose. So we'd have 120 tons of scrap daily, just from here, spread all over the country. That happens today with other materials that don't have a market for recycling.
Aluminium has a market because it's the miracle metal. It's roughly 1/3 as dense as copper or steel, so it weighs much less. It resists corrosion, and it's easy to work. Only gold is more malleable. It's one of the most versatile metals.
Você usa cerca de 7 toneladas de latas.
You use about 7 tons of cans to make around 6.3 tons of metal.
De metal.
It's a violent process. The raw aluminium shreds into pieces the size of a potato chip, then onto a separator to remove all traces of other metals.
Then the cans are sent pneumatically through those tubes to the stocking silos, where they will be taken and thrown into the furnace.
Out of the silos, into the fire. Mixed with the cans is aluminium scrap from can factories. Natural gas heats the furnace to 780 degrees Celsius, 1/10 the surface temperature of the sun. Paint melts. Metal fails. At last, the can's identity vanishes, and a solid becomes a liquid.
Todos que estão aqui são já bem antigos de empresa.
All of us who have been with the company for a while, we never get tired of seeing the metal tap.
Ele tem brilho mágico. Aí você olha, você fica.
It has this magic glow. You look and you are hypnotized.
Por aquele metal vazando.
To preserve its purity, the molten aluminium is skimmed like soup. A thin film of oxidized metal is removed to be remelted. the liquid aluminium isn't yet ready to change back into a can. Next stop, the processing plant. Novelis has the largest aluminium recycling plant in South America. It's the only plant in Brazil that can produce aluminium sheets for soda cans. The process begins with molten aluminium, turned into a giant block called an ingot. This single ingot weighs 15 tons, about the weight of 8 average cars. This plant processes the equivalent of 14 blocks per day, 5,300 blocks a year, 80,000 tons of aluminium. They look like ordinary hunks of metal, but they can take infinite forms. In weight, this amount of aluminium equals 1 Queen Mary, 8 Eiffel Towers, 450 Boeing 747s, and 4,640,000,000 soda cans. The most recycled object on the planet. The challenge? Making a half-ounce can from a 15-ton block. It happens with heat and pressure. Workers heat the ingot to 550 degrees centigrade to soften it for rolling. At the outset, it's about half a meter thick. They roll it like pastry dough up to 15 times. By the end, it's 90% thinner, about as thick as a video cassette. They trim the rough edges and catch the scraps to be remelted and recycled. After cooling, they roll the ingot again. Under enormous pressure, it flattens to 2 millimeters, about the thickness of a coin. Finally, coiled for shipping to a can factory. One coil may be 3 kilometers long and contain aluminium from more than 1 million recycled cans. Mrs. Macedo's can becomes a can once again. Not just this once, but over and over again during her lifetime and beyond.
So you have an idea what a can like this means nowadays in Brazil. Everyone knows that today, this means money.
Business launched Sao Paulo's green revolution. Now government is catching up. The city has planted 58,000 trees to help reduce pollution and added 2,000 square kilometers of green space. In 2003, Sao Paulo launched an urban agriculture program to help feed and employ the poor and recover blighted land. The city toughened vehicle inspections to reduce emissions by 30%. Yet the bottom line, not just good intentions, still drives Sao Paulo's green revolution, and there's a long way to go. Today, Sao Paulo is tapping hidden riches in unlikely places. From a crucible of change, a recycled river of liquid gold. Outside Sao Paulo stands a conundrum. This mill turns out a product crucial to the city's survival. Steel for cars, trains, buildings. Yet it also once churned out emissions that fouled the air, poisoned the water, and threatened the city's survival. Today, the Cozipa steel mill has cleaned up its act. Recycling is the future, and the plant has seen the light. Cozipa is spending $250 million on cutting-edge equipment to recapture or recycle pollutants at every stage of production.
Basically, for each production piece of equipment, there is a corresponding pollution control piece of equipment. More or less, for each dollar invested in production, we have $1 invested in environmental control: air, water, or soil.
Antonio Malinowski is a plant engineer. In the new, improved Sao Paulo, the plant fits right in. Cozipa is no stranger to recycling. They make their main product partly from scrap. Steel is the world's most recycled material. Each year, plants recycle 400 million tons of steel, enough to construct almost 1,000 Golden Gate bridges. Unlike an aluminium plant that recycles only cans, Cozipa recycles any scrap steel. Appliances, cars, ships, trains, even the guts of old buildings.
This is where we start the process of refining the steel.
As with aluminium, it begins with fire. They load scrap metal into a gigantic cauldron, then add an impure form of iron called pig iron. Here, the ratio for making steel is 20% scrap and 80% liquid pig iron, heated to 1,350 degrees Celsius. The cauldron holds 140 tons of metal, the weight of 2 Boeing 757s. A chemical reaction refines the scrap and iron into steel. Until half a century ago, refining took place in open hearth furnaces, a time-consuming method that took up to 9 hours. Today, it takes less than 45 minutes, thanks to a wonder of modern engineering, the basic oxygen furnace. The oxygen furnace dates to the 1950s, but now this Sao Paulo plant is refining the refinery and taking steel production into the 21st century. Cozipa is only the world's second steel mill to license a process called cojet technology, a truly supersonic innovation. The technology turned this man-made volcano into a supernova. It begins with a stage called charging, loading the furnace with scrap metal to control the extraordinary temperatures of the process. Then, up to 300 tons of molten iron. Next, a hollow lance with a patented tip blasts a laser-like jet of 99% pure oxygen into the steel bath at Mach 2, twice the speed of sound. The temperature soars to 1,350 degrees Celsius, 1/5 the surface temperature of the sun. The yield, liquid steel of exceptional purity, but still flawed. Impurities that could weaken the steel remain. Engineers add limestone to absorb them. The impurities float to the surface in a layer called slag. In the last stage of refining, the liquid steel is tapped and the slag is separated. Even the waste is not wasted.
The slag inside the converter can be used for many things, mainly road paving and also fertilizers. So this liquid slag will be cooled and transformed.
Making steel can be lethal. The hazards? Constant movement, mammoth weights, and hellish temperatures. The molten metal is so hot, it will instantly vaporize flesh. In the final stage, the refined steel becomes a long slab, cut at roughly 5-meter intervals for transport.
This product can vary from $500 to $600 a ton. Each plate weighs about 10 tons, so we can evaluate this load at around $300,000.
With prices like that, a steel mill like Coziba is a gold mine. A high-tech alchemist slab that transforms pig iron into treasure. Yet Sao Paulo's greatest feat of alchemy doesn't happen with scrap metal or even soda cans. It happens with an ordinary carton you find in your refrigerator. It's called Tetra Pak. This wonder material holds your morning juice, your lunchtime soup, your bedtime milk. It looks like simple cardboard. It's actually an ingenious blend of 6 layers of paper, plastic, and aluminium, fused tightly together. Paper stiffens the package. Plastic keeps it watertight. Aluminium blocks light and oxygen to prevent spoiling. Just one problem. Tetra Pak is so well made, no one could separate its components for recycling. This wonder material has always wound up in the dump. Until now. And the problem was solved right here in Sao Paulo. To grasp how a Tetra Pak carton is reborn, you first have to see how it's made. This is a Tetra Pak factory outside Sao Paulo. The first step is the one you'd think would come last: printing. To protect the environment, they use water-based paint. A precisely timed strobe light controls the quality of the printing. Though the paper appears motionless, it's actually moving at 180 meters per minute. The flickering light freezes motion to the naked eye. Fernando von Zuben is the environmental director of Tetra Pak Brazil.
What he's doing here is checking to see if the product quality is good or not. If it's not, the computer will send a message so that the paint will be corrected for the printing.
Next, laminating the paper with alternating layers of polyethylene, a plastic, and paper-thin aluminium. Finally, they cut the spool for shipment to packaging factories to become milk cartons, juice cartons, and soup cartons. Those cartons end up here. Now the cycle of rebirth begins. It starts with the same trash pickers who collect aluminium cans. Sao Paulo's catadores retrieve the Tetra Pak and haul it to a collection center. Here they salvage all kinds of paper, including cardboard. Brazil is one of the largest cardboard recyclers in the world. It recycles 76% of all the cardboard it produces. The collection center breaks down the Tetra Pak containers and bales them for transport to a paper plant. Sao Paulo has one of the largest paper plants in the world, Klabin. Like Tomra's aluminium recycling plant, Klabin operates 24 hours a day, 7 days a week. Each day, it produces 200 tons of recycled paper. The ingredients: 3 parts corrugated cardboard, 1 part Tetra Pak.
This whole factory works based on recycled material.
The material goes into a large blender called a hydropulper. Water turns it to pulp. During agitation, the paper in the Tetra Pak separates from the layer of plastic and aluminium, which are sifted out for use later. After about 20 minutes of agitation, the hydropulper recovers more than 90% of the paper fibers in a Tetra Pak carton. Those fibers now become paper again, new and improved.
When you add the fiber of the Tetra Pak container, you improve the quality of the recycled paper. Why? Because the fiber of the Tetra Pak container is virgin and the cardboard fiber has been recycled many times.
Almost every paper fiber that entered the hydropulper ends up as recycled paper, destined to become cardboard boxes.
This is the end of the process.
Not quite. The rest of the Tetra Pak carton waits to be recycled. Fused layers of aluminium, plastic and paper residue. Inseparable and unusable. Yet while other cities threw this residue away, Sao Paulo invented one use: roofing tiles. They finally shred the plastic aluminium residue, then press it on a corrugated mold. The tiles are hard to top, tough, durable, waterproof, heat-resistant, and up to 10% cheaper than regular roofing tiles.
These tiles are extremely light and efficient. Today we have 11 factories making these tiles around Brazil, using 700 tons a month of plastic and aluminum from the Tetra Pak containers.
Separated, the plastic and aluminium would be even more valuable. But leaving the hydropulper, they are inextricably mixed. Scientists can split the atom, yet for years, no one could pry apart Tetra Pak.
We ended up sending this material to landfills, not only wasting important raw material, but also causing an environmental impact.
Roberto Zente is Technical Director of TSL Environmental Engineering. They gave him a mind-boggling mission: crack the Tetra Pak enigma.
This is the problem. You have a thin layer of aluminium. You can see how thin it really is. Sometimes it's even transparent. And another layer of plastic. This aluminium, because it's so thin, it oxidizes when it's exposed to air.
In other words, it rusts. And rust creates a catch-22. To break up the oxide and recover the aluminium takes extreme heat. But extreme heat can destroy the plastic.
So the hard part is to recover the aluminium, which requires high temperatures, and at the same time transform the plastic into a usable product.
Working with a consortium in Sao Paulo, Zente finally cracked the problem. The technology is so new, the first full-scale plant has just come online. This test site demonstrates the ingenious solution.
The material is put here and fed through a piston. Then it enters a reactor where the process starts.
The reactor isn't nuclear, it's plasma.
Plasma is a gas heated by electric energy in the shape of an electric arc. Those old Frankenstein movies where you see a sphere send an electric charge to another sphere, that's an electric arc.
Like Frankenstein's lab, the plasma reactor produces a transformation that long eluded science. An electric arc creates a plasma jet, superheated to 15,000 degrees Celsius, almost 3 times the surface temperature of the sun. The plasma jet dissolves the stubborn bond of plastic and aluminium. Paper residue burns away, and like magic, wax and metal separate. The plastic emerges as a gas to be turned into paraffin wax. The aluminium emerges as molten metal, 99% pure. Emissions during recovery, almost nil. A monster of a problem solved by Frankenstein's technology. The plasma breakthrough revolutionizes recycling in Sao Paulo. For the first time, all three Tetra Pak components, paper, plastic, and aluminium, will return to the production chain as raw materials, bringing the cycle full circle. The breakthrough brings a windfall. The value of a used Tetra Pak carton could increase up to 30%. Now, Sao Paulo is exporting its recycling know-how throughout the world, even to technological dynamos like Germany.
This way, we were able to introduce Tetra Pak recycling in many countries where it didn't exist, simply by adapting technologies developed here in Brazil.
Yet an ugly obstacle to recycling persists at home, right in Sao Paulo's backyard. Waste on a grand scale. Costly, ugly, and lethal. How do you recycle a city that already died? In the 1980s, hell on earth had an address. An industrial center outside Sao Paulo. Cubatão earned an infamous title, the most polluted place on earth. Less than 60 kilometers from the heart of Sao Paulo, steel mills, chemical plants, and fertilizer factories spewed a lethal brew day and night. Pollution defoliated the surrounding mountains and triggered mudslides. The Cubatão River died. Cancer rates soared to 6 times the norm. Babies entered the world with birth defects, without brains, stillborn. In the shadows of Sao Paulo, Cubatão was dubbed the Valley of Death. In the 1990s, the government began forcing factories to clean up their act. In the spirit of the new Sao Paulo, Cubatão has reinvented itself. Factories invested billions to upgrade plants. They installed scrubbers to curb pollution, and waste was no longer wasted. Today, the water, air, and land are so much cleaner. Cubatão has been recognized as a model turnaround by the United Nations. From its suburbs to its core, Sao Paulo is recycling its image, one building at a time. This was once a factory that turned trash into fertilizer. Yet it was the one place in Sao Paulo where recycling didn't work.
Era uma usina que produzia composto orgânico de má qualidade.
It produced a very low-quality manure because the organic matter was mixed with glass, plastic, batteries. It smelled awful and the neighbors hated this place, couldn't stand it.
Tinha ódio disso aqui, não suportava.
Adriano Diogo once served as Secretary of the Environment for Sao Paulo. The transformation began on his watch.
E depois de 40 anos de funcionamento,
After 40 years, they made it stop. And what happened was, something had to be done with this place. These damned hated the place with a bad reputation.
It was the ultimate test of recycling. How do you reuse something with no earthly use? The answer? A brainstorm. Instead of a trash factory, an idea factory. A place where visions take shape. Instead of turning trash into fertilizer, they turn it into art. Everything they create, they make from garbage. The artists are local kids, the children of carpenters, steel workers, and trash pickers.
que talvez nunca entraram numa galeria de arte, nunca souberam o que é uma oficina.
Maybe they never entered an art gallery, never knew what an art workshop was. But with the familiarity they have with these materials, they started to work very easily with glass, plastic, cans, aluminum, iron, wood, and this space transformed itself.
In turn, the space has transformed the students. Now they work with one material above all: faith.
O simbolismo é a coisa principal, o simbolismo da transformação.
The main thing is the symbolism of the transformation in a city like Sao Paulo, so arid, so violent, so hard. It has room for a trash factory to become an idea factory, an art center.
After a long nightmare, where life was cheaper than trash, Sao Paulo wakes to a brilliant dawn. Now they don't mine a mountain of metal, they reshape it. They don't fell a forest of paper, they recycle it. They don't throw out acres of energy, they harness it. The greatest reclamation project of all, salvaging lives.
Eu me acho uma pessoa não só forte.
I think I am a person, how can I say it, not only strong because of my tiny frame, but I also think I'm a very courageous person. Courageous because not many have the courage to do what I do. I feel happy.
Me sinto vitoriosa.
I feel victorious. Thank God.
There's a long way to go, but Brazil is walking very fast in the right direction.
A long way to go indeed. But Sao Paulo's green revolution of recycling runs on the most powerful of fuels: cash. This megacity's destiny lies at the intersection of good business and goodwill. The road ahead is open, and there's no going back.